Okay, in this section we are introducing the terminology and the vocabulary related to polynomials, and we're also going to talk about adding and subtracting them. At the very beginning of your notes there's a bell ringer, so a practice problem to help you prepare for the absolute value quiz, so you can work through that. See the guided notes key for your answers on that if you want to check your work. Again, today we're going to talk about being able to identify parts of an expression. So what makes the different parts of an expression? How do we communicate those with the correct vocabulary? We're then going to classify an expression, or particularly a polynomial, and then be able to use what we know of like terms to apply the operations of addition and subtraction. Okay. So I've given you some definitions off to the left. We're going to talk about those and then give you a few more examples. So first of all, polynomial. We use this term a lot when we're talking about particular expressions. So by definition, this is an expression consisting of various terms. The word term, the way we combine these is through addition or subtraction. So when we use the word term, if I'm looking at this expression right here, this would be one term, and then it's separated from the next term by that addition sign, which is separated from the next term by that negative sign. So this guy would have three terms. Notice the one below, right? This right here, we would look at as one term, separated by addition and subtraction. So a polynomial is just a compilation of terms. Now, polynomials in particular, they don't have negative or fractional exponents on variables. So they can have negative exponents, just not on variables. They can't have variables inside radicals or variables in the denominator. So essentially a polynomial is actually a very friendly expression. It doesn't have any of these crazy things inside of it. So looking off to the side, we could kind of classify if these are polynomials or not by looking for any of those crazy exceptions. So if we look at this first one, 2x to the fourth plus 5x minus 1, that would be considered a polynomial. The next one has 3x to the negative third plus 2. This would not be a polynomial because it has a negative on the variable. Okay. Looking at the next one, notice we do have a radical in here, but it's in front of the variable, and it can be the coefficient meaning in front of the variable. So this guy is a polynomial. The next one, again, has a fraction value there, but the variable is not down in the denominator, so it's still a polynomial. And then this last one is not a polynomial because that variable is underneath that radical. So again, the ones we like here, right, are polynomials. They actually are the most friendly looking ones. So we're going to work with those first. Three different types of polynomials that we're going to name in particular are listed here. So one is a monomial. Remember, mono means one. So this is a polynomial that has only one term. A binomial is going to have two terms, and a trinomial will have three terms. Okay, mono, bi, and tri. Let's do some examples of those. So a monomial here, if I'm doing some examples, would be something like 3x squared. There's no addition or subtraction sign separating terms. Another example would be like 10xy. Again, there's multiple pieces to that term, but there's only one term. And again, that would be like a two-variable monomial. Or we could just have a number. That's also a monomial. Okay. A binomial then has two terms. So 4x plus 1, there's two terms. Or 10 minus y squared, there's two different terms there. Okay, and then a trinomial, again, will have three terms. So like 4x squared minus 3x plus 7. Okay. Moving down, we find or classify polynomials also by their degree. So the degree, we're going to talk about two different types. If we're just talking about the degree of a monomial, so a single term, the degree of a monomial is the sum of all of the variable exponents in the monomial. So in other words, how many variables do they have? So if we look at this first one, again, that's a monomial, just one term. Its exponent here, right, there's only one variable sitting there. So the degree of that term is going to be 1. If we look off to the right, we have negative 4m to the third n squared. There's 3 m's here and 2 n's, so total there's 5 variables where we take that sum, and the degree of that term is 5. Okay, then looking down at the 56, this doesn't have any variables, so its degree can be 0. Okay, once we start putting terms together, then we have a polynomial, and if I want the degree of a whole polynomial, then I just look for the greatest or the highest degree of all the terms. So for example, when I look at this, there's this term and this term. Well, this term has a degree of 1, this one has a degree of 2, so the highest or the greatest of all its terms is just a 2. Okay, this next one, there's 3 terms, and the highest degree or the highest exponent is going to be the 5, making the degree of the polynomial a 5. Okay, and when we understand what degree is, then we can write our equations in what we call standard form. So standard form, the definition is down here. We've got the exponents of the terms decrease from left to right. So notice even in the example we looked above, and we would have negative x to the fifth. Fifth is the highest exponent. Then we have a term that has a degree of 1. We don't usually write the 1, but there's a variable there. And then we have our negative 1 with no variable parts. So something not written in standard form, so if we were looking at something, a counterexample, that would be something like maybe we have 3x, right, plus 3x to the fourth. So now there's a higher degree on this side, and 7x squared. Those are all out of order because you have a highest degree right here, and then the squared, and then the 1 is clear over there. So we'd rearrange those so they were in standard form. Once you put it in standard form, then we can identify what we call the leading coefficient. This is the first coefficient when it's written in standard form. So if we come over here and we have a polynomial, let's say we have 3x squared plus 10, that's in standard form. So right here I have a leading coefficient. It is the number that is leading the standard form equation. And remember, coefficient means the number in front of the term. So the x is the variable part, the 2 is the exponent, the 3 is the coefficient. Okay, so let's practice this a little bit with this table. One more thing before we jump into the table. We talked about we classify polynomials by the number of terms. It's either monomial, binomial, or trinomial. Or if there's a lot of terms, then we just say n terms. So if there's 10 terms, we'd say a 10-term polynomial. We also then look at the degree. So we just talked about degree. If the degree is 0, right, there's no variables, then we call this a constant polynomial because it stays the same value all the time. If it's linear, the degree is 1. That would make a straight line. If it's quadratic, it has a degree of 2. Cubic, just like it sounds, a degree of 3. And then quartic, you can see where we're going with this. It's just going up. And a quintic is a degree of 5. Now anything bigger than that, we're just going to say something like a 12th degree polynomial. So anything bigger, just use the number that you found for your degree. So let's fill in this table below, kind of moving these things around. So our first example here, we have negative 3z to the fourth. Now there's only one term there, so he's already in standard form. So negative 3z to the fourth. The leading coefficient, again, is the number leading the standard form, so we have negative 3. The degree is the highest exponent. The only exponent there is 4. So again, this one has a degree of 4, so we're talking quartic. And then it has one term, so it's a monomial. So this guy right here, we're going to write as a quartic monomial. Okay. The next one, again, if we're writing this in standard form, we're going to look at this equation and we're going to find the one with the highest exponent. 5x squared has the highest exponent, so it gets to go first. The next one that has a variable is this guy on the right. So negative x gets to go next, and then very last would be that 4. Again, 4 doesn't have a variable, so it goes at the end. Leading coefficient is the number out front, so the 5, and then the degree there would be 2. Again, this one has 3 terms, so we know that it's a trinomial. And if we look at its degree, we got a 2. So if we look up at our quadratic, that says it's a degree of 2. So this one is a quadratic trinomial. Okay. Now I would encourage you just to maybe stop the video and try the next couple, see how you do with it, and then I'll go through and you can check your answers with this. So maybe pause and then go through and check this. So this is 9 and 1. This one's already written in standard form with a leading coefficient of 4, a degree of 3. Again, this one has 3 as its degree, so it's cubic, and then it has 3 terms. So it's a trinomial. The last one is only the numerical value of 8, so it gets to be its own leading coefficient. There's no variables, so this is the one we'd say is a degree of 0. And this is, oops, not linear. Degree of 0 is constant. And there's only 1 term, so we call it a monomial. Okay. Once we understand the different terms and writing them in standard form and understanding exponents, then we can start to add and subtract and multiply and eventually divide these polynomials. So what I want you to realize is that you've done something like this before, so I'm going to write this up here. You've done things like 10x plus 1, right? That's just like a little linear equation, and maybe we added 2x minus 5. And if you had an expression like this, we kind of practiced these already, you just found the ones that had x's. And if there were 10 x's and you add 2 more x's, that means you have 12 x's total. From there, you looked at the ones without x's and you said if I have a positive 1 and I subtract 5, then I end up with negative 4. This is just adding polynomials, okay? The only difference is now you're going to have terms with higher exponents. So the first thing you're going to do is identify like terms. That's step number 1. When we say like terms, remember like terms, they have to have the same variable part and exponent. So if I'm looking at 2x squared, that's similar to 5x squared. Those are like terms. If I have 3x squared and 5y squared, these are not like terms. Okay, they have different variables. If I have 2x and 5x, let's do 5x squared. These are not, because one has an x and one has an x squared. So they have to have the identical variable and identical exponent on the variable. Okay, and then we combine them like you're used to. So let's jump down here. Notice that we are adding, so we always look here to see what operation we're doing. This is addition, so we're just adding like terms. Nothing else is changing. They throw parentheses in there to show 2 separate polynomials, but it's just addition. So we find things that are like terms. I like to start with the one with the highest exponent just because then it's already in standard form when I'm done. So we have a 2x cubed here, and we have an x cubed here. If it helps you to write a 1 out front so that you remember there's 1 of them, you can do that. So if I have 2 and I add 1 more, I get 3x cubed. Okay, if I then look at my x squareds, so I have negative 5x squared, and it looks like there's another x squared here. Negative 5 plus 2 gives me negative 3x squared. Notice now I have a positive x here, but I don't have any other x terms, so he just gets to come down into our equation. I also have a negative 1 out here with no other like terms there, so it just gets to go at the end. This right here would be our final simplified polynomial. Notice there's no more like terms and everything is in order. On the right, this is labeled as vertical method. This is the same exact problem actually. However, if it helps you to stack terms, you can do that. So sometimes if I find a like term like this x cubed, I can put them underneath this one. And then my x squareds, I can put them under the other x squareds. X doesn't have a like term, and then I need to put my negative 1 somewhere, so maybe I bring him over here. And then it's like an addition problem. So for some people, it helps to kind of stack them up. So again, I have 2x cubed and I add another 1. That gives me 3x cubed. I have negative 5x squared, and I'm adding 2x squared, so negative 3x squared. If it doesn't have a like term, it just comes down. Same with that negative 1. So you'll get the same answer, just a different way to organize the work. Okay. Then with subtraction. So notice subtraction, and we've kind of put the rule over here separately. We added a step 0, meaning it's going to come before you start combining like terms. You want to take care of the negative or the subtraction sign. So you're just going to distribute this negative or this subtraction into the parentheses right behind it, right? Parentheses mean multiplication or distribution. So we just want to change those first. So if I start to distribute the negative, right, a negative times a negative, that's really going to be like plus 2n squared. This negative is going to change the sign of this. So instead of being a plus 2n, it's subtracting 2n. The negative multiplies to the other negative at the end, creating a positive 4. Once you've done that, you're done with that. Okay, you've changed those terms, you've taken care of the negative, now we can just combine them. So I have a 4n squared here, I have a 2n squared here. I add those together and I get 6n squared. Again, this one has a variable, so I'm going to go to this one next. This has a negative 2n, but there's nothing to combine it with, so I'm just going to bring it down. And then it looks like we've got a 5 here and a 4 here. Different shapes help us recognize different like terms. So 5 plus 4, positive 9. Again, I just checked to see if it's in standard form. It looks like it is, so we're good there. And again, the problem on the right is the same thing, just you can stack them if you'd like, but I would still distribute the negative first and make sure we're good there, okay? Let's do one more of each of these just to make sure we're good. These are 4 different examples if you'd like to do them. Let's just look at one on the, let's do the first one. So we've got x squared here, so I look for another x squared. Notice it's addition, so I'm not worried about distributing the negative. If I add 1 here to my 7 here at the end, I get 8x squared. I then have a negative 1x. Again, I'm going to put a 1 there to help me see that there's a 1. And I have a negative 1x, which makes negative 2x. And then lastly, this negative 2 doesn't have anything to combine with, so it just comes down to simplify. All right, I'm going to jump down and do the next one. Again, I look here first. This is subtraction, so I'm going to distribute that negative. So again, a negative times a negative is going to be plus 4p squared. A negative times a negative plus p. Negative times 3 minus 3. Again, once I'm done, I don't want to get confused about the negative, so I'm done with that part. Okay. Then we'll find some like terms. 2 is the greatest exponent, so I'm going to look at the p squareds. I've got 4 over here, and I've got 1 at the beginning, so 1 plus 4 is 5p squared. I then have 1p here in the middle. I have 1p here, so 1 plus 1 gives us 2p. And then you have a positive 3, and you have a negative 3, so those add to 0. So we don't need to write the 0. We're just done at 5p squared plus 2p. Okay, so on your assignment, you're practicing naming polynomials using that correct language and vocabulary. And then when you get to this part, you're practicing combining those like terms. So something you've done in the past, but applying it to terms with higher exponents and making sure that we're keeping track of those negatives.